So you count your terms and you understand how to count your terms. So let's start with the smallest one. Let's say we have two terms. There's three different techniques if you have two terms. There's the difference of squares, there's the difference of cubes, and then there's the sum of cubes. I just got an email. So depending on what your situation is, if you have two terms, you're going to choose one of those three techniques. The difference of squares, the difference of cubes, and the sum of cubes. Now let's look at each one of those bit by bit. So let's say you go through and you count your terms and you have two terms. So there's three techniques you can use if you have two terms. So one of them is the difference of two squares, which we're going to talk about right now. And then you also have, if you scroll down, you also have the difference of cubes and the sum of cubes. Okay, we're going to focus on difference of squares. Okay, if you have difference of squares, it's kind of like, here's a generic rule right here. Difference of squares says, okay, you have two terms and the terms are squared. And then there's a subtraction sign in the middle. If you have two terms and both of those terms are squared, you can take the square root of each one of the terms. And then there is a subtraction sign in the middle. Then you have a situation where you have the difference of two squares. Now, this is just the generic form. Don't be intimidated by that. Generic form just means, you know, we're creating a rule that you can use with any situation. Let me put some real numbers here so it's not as intimidating. Let's say I have x squared minus 25. Okay, if you're talking about factoring this problem, you first look for a GCF. I'm going to continue to go through the steps. Look for a GCF. Is there a GCF with this problem? Is there a common number? No. Is there a common variable? No. So there's no GCF. So I go to the next step. The next step is to count the terms. Count the terms. How many terms do you have? 1, 2. Okay, 2 terms. And can you take the square root of each one of these terms? And that answer is yes, because the square root of x squared is x. The square root of 25 is 5. Okay, that's how I know I have the difference of two squares, because I can take the square root and I also have a subtraction sign in the middle. So what do? The rule says if you have two terms that are squared, and I'll finish this one off over here. If you have two terms that are squared, you take the square root of each term. This one will be A. This one will be B. And you write a binomial, one with a plus sign and one with a minus sign, using those two square roots. So I took the square root of each term, and then I wrote one binomial. And what I mean by binomial is just two terms. I write one binomial with both of those square roots, and then I wrote it once with a plus sign, and I wrote it once with a minus sign. So if I go back to my example over here, I took the square root of each term. The first one was x, the first one was 5. Now I'm going to write a binomial, one with a plus sign, and then one with the minus sign. Right? So let's look at another example. Let's say I have, 121. Okay. Is there a GCF? No GCF. No numbers in common. No variables in common. How many terms do I have? 2. Can I take the square root of each term? Yep. Square root of the first one is x. Square root of 121 is 11. So now, in order to factor this, I'm going to write this once with a plus sign using my square roots. And then I'm going to write once with a subtraction sign using my square roots. So that's how you do the difference of two squares. It's fairly simple. You just gotta remember the rule. That's a lot of times in math, like the rule is pretty straightforward, but the problem is you just have a whole bunch of rules you have to remember. So let's look at another example. I am completely making things up. Look at this. So first step in factoring. Let's take out a GCF. Is there a GCF between 25 and 36? Is there a number that can be divided evenly into both of these? No. Only thing goes into 25 is 5 and 25, and 5 does not go into 36. So no GCF. How many terms do I have? 1, 2. So that's why I'm using my techniques for 2 terms. And can I take the square root of each one of the terms? In this case, yes. The square root of 25 is 5. The square root of y squared is y. Square root of 36 is 6. So I took the square root of this first term, which was 5y, and I took the square root of the second term, which is 6. Now, those 2 square roots, I'm going to write it once with a plus sign. And I'm going to write it once with a subtraction sign. And then that is completely factored. Not too bad, not too bad. Okay, let's look at another example. Let's look at 3. Okay, let's look at this example. 3x squared minus 300. So, is there a GCF? I'm going to continue to ask the same questions. Is there a GCF? Just so we can consistently use the same techniques. In this case, yes, there is a GCF. There's a number that goes evenly into 3 and 300. And that number is 3. What do we have? Is there a variable in common? No variable in common. Only have the x squared, but it's not in both of the terms. So let's write what we have left in the parentheses. X squared, and then minus 100, because 300 divided by 3. Now, look inside the parentheses. Can you factor that? Can you take the square root of each term? Yep, that will be an x. 100, this will be 10. So yeah, we can keep going. So this will be, we got the 3 in the front, and I'm going to write the x and the 10 once with a plus sign, and then I'll do it again with the subtraction sign. Definitely. So that's how you do the difference of 2 squares. Now, special case here. Let's say we have this problem. Okay. All right. So first step in factoring, you're going to get tired of me saying that. What's the first step in factoring? Take out a GCF. Is there a GCF in this problem? No, no GCF. So now let's see if we can take the square root of each term. Yes, the square root here is going to be x. The square root of 49 is going to be 7. But there is a problem. The rule says the difference of 2 squares. Difference means subtraction. So if you don't have the difference of 2 squares, which all of these had subtraction in them, the rule has subtraction. If you don't see the difference of 2 squares, then you can't even factor it. Because you have an addition sign here, this one cannot be factored. So what they usually call this is prime. It's kind of like a prime number. You know, when you have a prime number like 7, there's no numbers you can multiply together but 1 and 7 in order to get 7. That's why they call this prime, because there's no 2 sets of parentheses you can divide this up into, or not divide, but factor it into in order to get x squared plus 49. So be careful with that. I should put a big warning here. Warning. If you have a plus sign, you cannot factor it if you're talking about squares. Okay, so even here, like if you had something like this, let me make this one change here. I can't factor this. I can't even take out a GCF because of the plus sign that's in the middle. Now, one more example I'm going to do, and then we'll switch to the next step, because I want you to understand this as well. So going back to that problem, let's say we had 2x squared plus 200. Okay, what's your first step in factoring? GCF. Take out a GCF. I look at the numbers. Is there a number in common? The number that they have in common is a 2. And then you're left with x squared plus 100. All right. Now you look inside the parentheses. Can we factor even further? I know I can take the square root. Square root of x squared is x. Square root of 100 is 10. But look what I have here. A plus sign. So because of that plus sign, I can't go the next step and say, oh, I'm going to write it once with a plus sign, once with a minus sign. Can't do that. So this, if they ask you to factor this, this is all you can do is take out a GCF. So you are able to take out a GCF. You just can't go further and factor that and say, oh, it's x plus 10 and x minus 10. Can't do that. Sometimes students will say this and say, oh, it's x plus 10. Just make both of them plus signs. Okay. Can't do that, because if you multiply all this together, you won't get the original back. So don't make that mistake either. So this is our difference of 2 squares. Okay, so now let's talk about the difference of 2 cubes and the sum of 2 cubes. So I kind of want to look at an example first before I start talking about the overall rule. So let's say you see a problem like this. Okay, let's say you see a problem like this. So first step in factoring, here I go again. First step in factoring, take out a GCF. So you look at 8, you look at 27, and you try to think of a number that divides evenly into both of those numbers. And there is nothing. 2, no. 4, no. 8, no. None of those numbers work. So there's no GCF. You look at the variables x and y. Of course, they are not common either. So there's no GCF. So you see a subtraction sign, and then you try to take the square root. Can you take the square root of 8? No, you can take the square root. It just won't be a nice clean number. Can you take the square root of x to the third? No, can't do that. Can you take the square root of 27? Again, you could, but it wouldn't be a nice clean number. And then y to the third, again, can't take the square root. So this is not the difference of squares, because you can't take the square root of these two numbers. But let's see if we can take the cube root. Now, if you can take the cube root of these numbers, then we could solve this problem. So if you think about the cube root of 8, the cube root of 8 is going to be 2. Uh-oh, wrong now. Cube root of 8 is going to be 2. The cube root of x to the third is going to be x. The cube root of 27 is going to be 3. And the cube root of y to the third is going to be y. So yeah, you can take the cube root of these terms. You can't take the square root, but you can take the cube root. that lets me know that I have the difference of cubes, not squares, but cubes. And this is another rule you could use if you have two terms. If you have two terms and you can actually take the cube root of those terms, then it's the difference of cubes. So before I put down the overall rule, I want to talk real quick about the cubes. Feel free to use a calculator to see this as well, but it will be helpful to know your cube roots the way you know your square roots. Like you may be able to say the square root of 16 is 4. The square root of 9 is 3. Like the way you're able to say that, you may need to do that with cubes as well, because there are some common ones. The cube root of 8 is going to be 2. It will be helpful to kind of memorize that. And that is an ugly 2, so I'm going to rewrite it. So the cube root of 8 is 2. The cube root of 27 is going to be 3. The cube root of 64 is going to be 4. The cube root of 125 is going to be 5. So I would at least memorize, I mean, you can go one more step if you want to. Is it 216? The cube root of 216 is 6. Like, I would go as far as memorizing these 5, just the way you memorize like square roots. Like the square root of 25 is 5. So I would memorize these because it will help you with problems like this. The reason why the cube root of 8 is going to be 2 is because if you multiply 3 2's together, you're going to get 8. Same thing with 27. The cube root of 27 is 3 because if you do 3 times 3 times 3. So that's how you figure out what cube roots are. 4 times 4 times 4. And likewise, okay? So it will be helpful to know your cube roots. Okay? Cube roots. So let me erase this. I want all this to go away. And while I'm erasing this, let's think about the rule that we need to use here. So there's 2 rules that we need to use when we're talking about the difference of cubes and sum of cubes. It's a formula. And depending on if you have a plus or a minus sign, will tell you what formula to use. So the one example that I have here on the paper is a subtraction sign. So it's the difference of cubes. So here's the overall formula right here. Let's say if you have a to the third minus b to the third. So these are 2 terms and they're both cubed. That tells me, and there's a subtraction sign in the middle. That tells me I have to use the difference of cubes. The formula for that is to, first of all, you take the cube root of each term, which is a and b, and then you plug it into this formula. First, you do a minus b. So whatever your cube roots are, you just subtract them. Then you do a squared plus a times b plus b squared. And remember, this is the generic form. It looks confusing right now because it's just the generic form. It just has letters in it. But once we put numbers in there, it should make a little bit more sense. So this is the generic form for difference of cubes. So let's use it, right? I'm going to rewrite this problem again so I have more room. I have 8x cubed minus 27y to the third. I'm going to put it right below the formula. So first of all, I need to take the cube root of each term, which I've done. This one is 2x and this one is 3y. And then I'm going to follow the equation that I have up here. So first it says do a minus b. This is representing my a and this is representing my b. So I do a minus b. That's going to be 2x minus 3y. Okay. Then it says do a squared. Remember, this is representing your a. I need to take this stuff in the circle and square it, all of it in the circle and square it. That's going to be 4x squared. Okay. Then it says do a plus sign. Then it says do a times b. So here's my a and then my b is over here. I got to multiply those two things together. And when I multiply those together, a times b, I'm going to get 6xy. Because you do 2 times 3. And then you put the x and the y together. So 6xy. Then it says do a plus sign. And then it says do b squared. So everything in the b circle, I take that and I square it. That's going to be 9y squared. And that would be your answer. That is fully factored. Let's do it again. Let's do it again. I gotta think of another example though. Okay. Let me write down another example. Let's do 64x to the third minus let's do 27 again. I'm not going to put a y on it, though. Okay. So, first step is to see if there's a GCF. And there's no GCF that I see. 3, no. 9, no. 8, nope. 2, nope. So, there's no GCF. And then I see if I can take the square root. So I can take the square root of this first term, but I can't take the square root of the x because it's to the third power. So that tells me I can't do square root. It's not the difference of squares. This is the difference of cubes. So you have to take the cube root. So the cube root of 64 is going to be 4. The cube root of x to the third is going to be x. Okay, so this is going to be representing our a. And then the cube root of 27 is going to be 3. And that's going to be representing our b. So this is like our a and this is like our b. So let's follow the formula. It says do a minus b. A minus b. So 4x minus 3. Then you do a squared. So I take everything in the a and I square it. So that's 16x squared. Remember to square the number and the variable. If it's a number and a variable, you got to square both of them. Then I have to do a plus sign. And then I do a times b. So if I multiply those together, I get 12 and then an x. And then I do b squared. And that's going to be 3. 3 squared is 9. So here's your answer. We've done difference of cubes. Now let's look at sum of cubes. So let's say that I have 27 z to the third plus 125. So first, is there a GCF? There's no GCF between 27 and 125. How many terms do you have? I have 2 terms. Can you take the square root? No, I can't take the square root. Can you take the cube root? You see how I'm talking myself through these questions? Can I take the cube root? Yes, you can take the cube root. Because the cube root of 27 is 3. Cube root of z to the third is z. So this is like your a. And then you have the cube root of 125, which is 5. This is going to be like your b. But we have a difference here. The difference between this and the one that we just did is this addition sign that I have here. Before it was a subtraction sign. You see? Now we have an addition sign, which means I need a different rule. So when you're talking about the sum of cubes, the formula looks like this. Let me do this in black. I'm going to put the formula right here. Let's say if I have two things that are cubed. First, I take the cube root of each term, which is a and b, and then I plug it into this formula. First, you do a plus b. Then you do a squared. Then you do minus a times b. Then you do b squared. Now notice the difference here. So with the sum of cubes, notice how this is set up. You do addition first and then you do subtraction and adding. If you go up here to the difference of cubes, you do subtraction and then the last two are adding and adding. Okay. So looking at these formulas side by side would probably be helpful to kind of see how the signs change here. And then look at this one. I would look at these side by side and kind of notice that I'll actually write them side by side after I do this example. So this is the formula that we're going to use. So let me rewrite the problem below and then we're going to fill in the gaps. So I had 27z to the third plus 125, right? We took the cube root, which was 3z. This was like our a. And then we took the cube root of 125, which is 5. This is like our b. And then we're going to write our formula in. It says first do a plus b. So that's 3z plus 5. Then it says do a squared. A squared is going to be 9z squared. Because remember, you have to square the 3 and you have to square the z. Then you do a subtraction sign and do a times b. If I do a times b, that's going to be 15z. So 15z. And then I do 5 squared, which is 25. And this is my answer. So sum of cubes and difference of cubes, it literally is once you take the cube root, you plug it into the formula and then you should be finished. Okay. But the formula is something you have to remember. So let me write these formulas side by side real quick, just to make sure we see them. I just want to be able to see them side by side. So I have the difference of cubes, where you take the cube root of each term, you write it once with the minus sign, a minus b, then you do a squared plus ab plus b squared. That's the difference of cubes. Now, the sum of cubes, let me show you the difference between the two. The sum of cubes, you still take the cube root of each term, but the signs change over here. You're going to start with addition now. And then you have a squared minus ab plus b squared. Okay. How I memorize these formulas, whatever sign it is how you start. And then it switches over here. When you go to the next sign, it switch. Okay. And then the last term is always positive. If it's squared, it's always positive. So same thing here. It stays the same. And then it switches. And then the last term always stays the same. That's how I kind of memorize, because it took me a while to figure out how in the world am I supposed to memorize this formula. Depending on your teacher, you may not even have to memorize it. You may just need to be able to use it. And that's the important part. Do you know how to use it? So, boom, that is how we handle two terms. So let's say you count your terms and you have three. Let's say you have three terms. There is, I would say three, but there's two things you got to look at. Let's just say two. There's two things you got to look at when you're talking about three terms. And that is there a number in the front or not? Okay. Is there a number visible in the front or not? Because depending on if there's a number in the front or not, that will determine what direction we're going to go in. So I'm going to talk about those two techniques, and then I will go even further into some other techniques you could possibly use in special case situations. Okay. So let's look deeper into three terms. Now let's discuss three terms. So on your handout, I have, is this a perfect square trinomial? Let's skip this for a minute. Uh-oh, here we go. I'm going to come back to this, okay? I promise I'll come back to it. But let's talk about, is the coefficient of the squared term 1 versus is the coefficient of the squared term different from 1? So let's talk about those two situations, and let me show you what I mean by that, because the technique will be a little different depending on if the squared term has a coefficient of 1 or not. So let me put an example up and we will go from there. So let's look at this example here. So this is considered to be a trinomial, a polynomial with three terms, right? 1, 2, 3. So we have three terms. But if you look at the first term, there's no number in the front. It's understood to be a 1, okay? Even though we don't see it, it's understood to be a 1 there. But we don't physically see a number sitting in the front. So that's what I mean by, is the coefficient of the squared term 1? In this case, you would say, yes, it is. The coefficient of the squared term is 1. So there's a technique that you can use for this particular problem. Versus, let's go to a problem like this. Okay, you see this problem? And look at the number in the front. It's a 12. So this has a number different than 1 in the front. It actually has the number 12. So the technique that we would use for this problem will be different than the one that has a coefficient of 1. Okay, let me put a couple of more examples up to show you. And I'm going to keep that there because I actually worked that problem out. Let's put another one up. How about this? Okay. So this is a trinomial, a polynomial with three terms, but the coefficient is 1 in the front. Okay, so there's a technique to use for this one. Versus if I had a problem like this. See, this is a polynomial with three terms, but the number in the front is something other than 1. So the technique would be different. So let's focus on the first one, right? Let's focus on this one. When you have your first term has a coefficient of 1, let's talk about what we do in that situation. So if you have a trinomial and the first term is 1, then we would make 2 sets of parentheses just automatically, and we would put a variable in each one of those parentheses. So I have the variable that I'm putting in there is an x because my original polynomial had x. So I have parentheses x, parentheses x. Now I have to figure out the number that goes inside of the parentheses. And so we play this little game where we look at the last number and we try to figure out what number can I multiply to get this last number, but when I add, I get the middle number. And so what I typically do is I make this little X thing. I say, what can I multiply to get 7, but when I add, I get -8. This just helps me kind of organize my thoughts. It's not required. It just helps me think about my numbers for a minute. What can I multiply to get 7, but when I add, I get -8? Think about, what do you multiply to get 7? There's only two numbers, 7 and 1. But I need to add these numbers to get -8. So I'm going to make both of them negative. -7, -1. That's going to give me +7 when I multiply. But when I add, I get -8. That's how I know I have the correct numbers. -7, -1. And I put those numbers inside the parentheses, and this will be my fully factored problem. Let's look at the next one. So this problem, I have 3 terms. There's 1 in the front, so I can do 2 sets of parentheses, right? An X in each one, because that is the variable that's being used in the polynomial. Now I have to figure out, what number do I multiply to get 16, but when I add, I get -10. Multiply to get +16, but when I add, I get -10. So what gives me 16? 4 and 4, 8 and 2. Let's try 8 and 2. I multiply those, I get 16, but when I add them, I get +10. So in order to get -10, I have to put a negative in front of each one. So multiply those numbers, you get +16, but when you add them, you'll get the -10. That's how I know I got the right numbers. And this will be your answer. All right, let's look at some more examples here. And see, when there's no number in the front, it makes it a little simpler than the ones that have a number in the front. I'm looking in my book trying to find something. So let's change the variable up. So is there GCF? No. How many terms do I have? 3. Is there a number in the front? No, it's just a 1. Okay, so that tells me, okay, so we can go ahead and go to this step here where you have parenthesis y, parenthesis y. Now we're trying to figure out, what number do I multiply to get -54? But when I add, I get the number in the middle, which is a +3. I need to multiply to get -54, but when I add, I get 3. So I think about the numbers that give me 54. I know I can divide 54 by 2. What's it, 27 and 2? That's not going to work to give me 3. What numbers? 9 and 6. 9 and 6 work. When I multiply 9 and 6, I get 54. But I need to get -54. So let me try put the negative with the 9. -9 and +6, that gives me -54. But when I add those numbers, I get -3. I need to get a +3. So let me change this negative sign to the 6, and I should have everything I need. 9 and -6 is 54. And then 9 minus 6 will give me 3. So I have the two numbers. It's going to be +9 and -6. So here's my answer. When you're trying to find those two numbers, I always look at, what can I multiply? I always look at the numbers I can multiply together to get the number and see if that can help me get to where I need to be. So let's look at z squared minus 3z minus 28. So is there a GCF? No. How many terms do I have? 3. Is there a number in the front? No. So I can do 2 sets of parentheses, and I'm going to put a z in each one. And so I need to find a number that when I multiply, I get negative 28. But when I add, I get negative 3. Multiply to get negative 28, but add to get negative 3. So 27 is 7 and 4. But one of those needs to be negative. I'm trying to add to get negative 3. So let's make the 7 negative. If I multiply those, yes, I do get negative 27. When I add those, I get negative 3. So yeah, that works. And here is completely factored. Another example. Let me do this example real quick. I want to do one more example before I move on to the other one. And I'm not sure where to write it. Let me do it on another piece of paper. I can do that, right? We'll do it here. Okay. So let's say I have this problem. Okay. Let's say I have this problem. Okay. First step in factoring is a GCF. Is there a GCF in this problem? When I look at the numbers, yes, there is a GCF. So I must do that first before I even start working the problem. I got to take out the GCF. So 2 is my GCF. I'm left with x squared minus x minus 12. That's what happens when I take a 2 out. Divide everything by 2. Now I look inside the parentheses. Now the polynomial that I have inside the parentheses, now it has a coefficient of 1. You see? So now I can factor that. I got the 2. The 2 is just hanging out until you finish. And so I'm going to split this up, x and x. And I need to find the numbers that go here and here. So what do I multiply to get negative 12? But when I add, I get a negative 1. This is like a negative 1 up here at the top. Okay. When you just see that negative sign there, that's like a negative 1. So what? 6 and 2. 6 and 2 doesn't work. How about 4 and 3? And you need to add these numbers to get negative 1. So let's make the 4 negative. So it's negative 4 and positive 3. I wanted to do this example because I wanted to show you what happens when you have a GCF. You still follow the same procedure, but you just got to do that first step of taking out a GCF first. Now, let's revisit this problem because we said because they're okay, let's revisit this problem. Because there is a number in the front, the technique is going to be different than our previous problems we worked. So that number in the front tells me that I need to do something a little bit more tedious than just making parentheses and putting the number in there. So I usually call this the AC method. The reason why I call it the AC method is because you're going to have to multiply this first number. Like typically this is the A, this is the B, this is the C. Typically you would multiply these two numbers together in order to figure out what numbers we need to play around with. So I call this AC method. Some teachers may call this something else. Some people may call it factor by grouping. I'm going to use both of those terms so you're just familiar with that depending on what teacher you go to. So if I have a problem set up like this and there's a number in the front, I have to find a way to split up this middle term. Okay. Notice I have 3 terms. I have to find a way to make 4 terms total. So I'm going to take this middle part and split it up into 2 different terms, but I can't just split it up any way I want to. I have to split it up in a certain way. And the way I figure out how to split it up is I multiply A and C. So I'm going to take A times C, which will give me negative 24. And then the number in the middle, the B part, is negative 5. So kind of like that same X thing that we did in the previous problem, but in order to get the number at the top, I have to multiply A and C. So I have to think, what number do I multiply to get negative 24, but when I add, I get negative 5? Multiply to get negative 24, but when I add, I get negative 5. I think 8 and 3, and then we'll make the 8 negative. So if I multiply those, I get negative 8. Negative 8 times 3, they'll give me negative 24. And when I add those, I get negative 5. So yeah, these are the 2 numbers. Now, what do I do with these 2 numbers? Those are going to be the numbers I use to split up the middle. So I'm going to rewrite my problem now. It's going to be 12x squared, now minus 8x plus 3x minus 2. Notice I don't have the negative 5 in the middle anymore. I changed negative 5 into negative 8 plus 3. I split it up using the numbers that I found in my x. So now I have 4 terms. You see? 1, 2, 3, 4. And I can do factor by grouping from here. So I do the AC method to figure out what are the 2 numbers I'm going to use to split up the middle. So once you have 4 terms, what you do now is factor by grouping. And what I mean by factor by grouping is you look at the first 2 terms. You can only do factor by grouping with 4 terms. That's why we had to change the 3 terms to 4 terms. So the way you do factor by grouping is you look at the first 2 terms and you take out a GCF just among the first 2 terms. So let's see, 12 and 8, that'll be 4 and then x. And inside my parentheses, I'm left with 3x minus 2. And then I look at the last 2 terms and I take out a GCF. When I look at the last 2 terms, I don't see anything in common. The only thing they have in common is a 1. I have to take out something. So if they don't have anything in common, they at least have a 1 or a negative 1. So I put a 1, and in the parentheses, I'm left with the same thing, 3x minus 2. Now, the way that I know that I'm doing this the correct way, because I got one more step, but before I go to that next step, I can check myself to see if I'm doing it right because these parentheses will be the same. If the parentheses are the same, you know you're going in the right direction. So the last step here is to take these 2 parentheses and bring them together as 1. So what I typically do is I cross them out and say, okay, I'm going to bring them together as 1. I got 3x minus 2. And then what I don't have crossed out is what I have left, 4x plus 1. And then this will be your answer. You see? So that 3x minus 2 is almost like a GCF that you're taking out. They're common, they're the same. You take them out, you bring them together as 1, and then you're left with 4x plus 1. You see how this is a little bit more tedious than just if there was not a number in the front, then you could do it, in a smoother way. So let's look at the next example. Okay, so let's try to do this second example, but I need to erase this because it doesn't work out. Sometimes when you try to work these problems out, if they don't work, it's because it's prime. It's a prime problem. That means it can't be factored, and that's okay. So sometimes when you're working through the problems, understand that some of them may not work out. And if they don't, it's just because you have a prime problem, and that would actually be your answer. You would just say, oh, this is prime. So let's try this example. Is there a GCF? The answer is no. How many terms do you have? The answer is 3. Is there a number in the front? Yes. And it's not 1. So that means we have to do this AC method or factor by grouping. That means I have to split the middle part up some type of way, but I can't do it any way I want to. I have to use the AC method where I multiply the first number and the last number. So think, what number do I multiply to get, what is this, negative 24? But when I add, I get negative 5. It's 8 and 3 again. That's a coincidence. I didn't mean to pick the same numbers. So negative 8, positive 3, if I multiply those, I get negative 24. But when I add those, I get negative 5. So that's how I'm going to split up the middle part. So I rewrite this. 6y squared minus 8y plus 3y minus 4. Notice instead of having negative 5y, I changed it to negative 8y plus 3y. Okay, so now I have 4 terms. Now let's do factor by grouping. So the first 2 terms, I'll look at the first 2 terms and take out a GCF. Between 6 and 8, that will be 2. And then I also have a y. And then in the parentheses, I'm left with a 3y and then minus 4. Then I look at the last 2. They don't have anything in common, so I'm just going to put a plus 1, which is okay. And then in the parentheses, I'm left with 3y minus 4. I know I'm doing this correct because my parentheses look the same. So I bring the 2 parentheses together to make 1. And then whatever I have, once I cross out the 2 sets of parentheses, which is a 2y plus 1, I put those in the next parenthesis, and then this is my answer. I can't believe I picked an example with the same number, so I'm going to do another one. It's okay. I can do another one. Let's get a new page, and I'm just going to write another example down. Let's do, I'm going to do something that seems just not extreme, but let's see. Let's do 3x squared plus 14x plus 15. I haven't worked this one out, so we're going to do this one together. So is there a GCF? No GCF. How many terms do I have? I have 3. Is there a number in the front? The answer is yes. So I have to use the AC method. And I have to find a way to split up this middle part. That's my goal. So I multiply the first and the last number. 3 times 15 is 45. I have to find a number that when I multiply, I get 45. But when I add, I get 14. So multiply to get 45, you got 15 and 3, you got 9 and 5. I think that's it, 9 and 5. And there's no negative, so both of these are positive. Multiply those, I get 45. When I add those, I get 14. So I'm going to rewrite my problem. Instead of using 14x, I'm going to use 9x plus 5x. Those were the 2 numbers that I found. And then plus 15. So I split up the middle part, and now I have 4 terms. So 4 terms automatically means factor by grouping. So boom, I'm going to look at the first 2 terms and take out a GCF. My GCF is going to be 3 and an x. And in the parentheses, I'm left with x plus 3. And then I look at the last 2 terms, and the GCF among the last two terms looks like it's going to be a 5, a positive 5. And you're left with x plus 3. Now, I feel good about this because, look, my parentheses look the same. That's always a good feeling. When the parentheses look the same, you can bring them together as one. If they aren't the same, then something is wrong. You need to stop and redo it. So x plus 3, and then what I don't have crossed out is the 3x plus 5, and that's what goes in the next parenthesis, and then this is done. Sounds good. I'm going to do one more. I want to do one more where I take out a GCF. Yeah, let's do that. So I have this problem. And I hope I wrote this down correctly. Okay, so is there a GCF? And when I look at this problem, yes, I do have a GCF. There's a number that divides evenly into 6, 9, and 42. That number is going to be 3. And they also have a variable in common that's going to be x. So 3x is my GCF. What I have left in the parentheses is 2y squared. Then I have 3y. And then I have, what is this? 14. Yep. So this is what I have left. Now I look inside the parentheses and it's like, okay, I can factor what's inside the parentheses. I have 3 terms. The first term has a 2 in the front. So that means I got to do AC method. So I'm going to ignore the 3x on the outside for right now. So inside, I just, actually I'm going to put like a red box around it so I don't forget it. So inside the parentheses, let's do an AC method, right? So 2 times negative 14, that's going to be negative 28. I need to find a number that when I multiply, I get negative 28. But when I add, I get 3. So I know 7 and 4, but I need to add to get 3. So the 4 will be negative. So that's how I'm going to split up the middle part. And let's rewrite our problem. 2y squared plus 7y minus 4y minus 14. So I just use the 7 and negative 4 to split up the middle. And what do I do next? Factor by grouping. So I look at the first 2 terms, take out a GCF, which is just going to, they don't have numbers in common, but they do have a y. So I put y, and in the parentheses, I'm left with 2y plus 7. And then let's look at the last 2. So the last 2, they have a 2 in common, but there's negatives. So instead of just a positive 2, I'm actually going to take out a negative 2. If I don't take out a negative 2, it won't look like the first parenthesis. So that's another reason why I need to take out that negative. So remember, when we were talking about taking out a GCF, we talked about that negative sign. That negative sign needs to come out if it's in the front like that. So now the parentheses look the same. Look, boom, boom. That's a good sign. Bring them together like 1. So 2y plus 7. And then what is not crossed out is the y minus 2. And before you put a box around the answer and say, oh, I'm done, don't forget that 3x. That needs to go in the front because that's part of your problem as well. When you take out a GCF, that GCF is part of your final answer. So this is completely finished. Okay, as promised, I said I would come back to this, and now here I am. So a perfect square trinomial, this is not a technique you can use with every single type of trinomial, but you could have a situation where you have a problem that looks like this. X squared minus 10x plus 25. So if you have a situation where you can take the square root of the first term, which is x in this case, and you can take the square root of the last term, which is 5 in this case, and you multiply those two numbers together, you get 5x. If when you double that, you get the middle, then you say that this is a perfect square trinomial. So if I take this and multiply it by 2 and I get the middle, then you know it's a perfect square trinomial. What you can do if you recognize that you have a perfect square trinomial is you can jump right to this as being your answer. You can take those two square roots, take the sign that's in the middle, and take the square root of the last term and just square it. So it's kind of tricky to notice this, but if you do, it could save you some time. So like for a problem like this, okay, if I eyeball this problem, okay, I got square root of the first, square root of the last. When I take these two numbers and multiply them together, I get 6x. If I double that, I get what I have in the middle. So if I recognize that by looking at it, then I can say, oh, let me just take those two square roots, the sign that's in the middle, and just square it and write it like this. Let's say you don't recognize that. It's completely okay if you don't recognize that, because if you just follow the traditional factoring techniques, then it will work out the same way. Okay, so if you follow your traditional factoring techniques, you would look at this and say, okay, this is going to be a trinomial. There's no number in the front, so I do 2 sets of parentheses, and I'm trying to find a number that when I multiply, I get 25, but when I add, I get negative 10. That's going to be negative 5, negative 5. I multiply those, I get 25. When I add those, I get negative 10. So those are the two numbers that go here. Now notice this is the same as this. Okay, it's just like a shortcut. So if you recognize a perfect square trinomial, then you could use this shortcut in order to solve it. It's not the most popular technique that I've seen among students, but it is a quick way to kind of, get through some of the problems if you have a perfect square trinomial. You can't do this with every problem. It's only if it's set up with a square root at the beginning, square root at the end, and then when you double it, you get the middle. That's the only time you can do this. I could do one more example real quick. So like, I'm trying to think of something that has a plus sign. Oh. Okay. So if I had something like this, take the square root of the first, square root of the last, I'll multiply them together. I get 8x. And when I double it, I get 16. Okay, cool. That means that this will be x, take the sign of the middle, plus 8 squared. Or you can just factor it traditionally. If you factor it traditionally, you would get this, which means the same thing. Okay. So one more section I want to talk about. Boom, we did trial and error. So trial and error is another section that's not completely popular among students, but some students like to use trial and error. So I'm going to go back to some of the problems that we've already worked out. And I'm going to show you how trial and error works. So if I had, let's use this one right here. So 12 minus 5 and 2. So 12x minus 5x minus 2. So instead of doing the factor by grouping, you can do this thing called trial and error, where basically you look at all the factors of the first term. So the factors of the first term is going to be, what do I multiply to get 12? 4 and 3, 6 and 2, 12 and 1. Am I missing any? So those are, if you look at all these factors, I can multiply them together and get 12x squared. Okay. And then if I go down here to the last term, let's think about all the numbers you multiply to get 2. It's only 2 and 1. That's the only two numbers you can multiply to get 2. So that, can't do anything else with that. So trial and error means you literally take the numbers, the possibilities that you have, and you try and you see if you get the correct answer just by guessing. So you're going to have 2 sets of parentheses. So let's start with 4 and 3. Let's put 4x here. Let's put 3x here. And then let's put 2 here. Let's put 1 here. This will be positive 2 and positive 1. So I'm going to try this to see if it gives me the right answer. The way you know if it gives you the right answer or not is if you multiply the inner terms, which is going to be 6x, and you multiply the outer terms, which is going to be 4x. If you add them together and get the original middle term, which is negative 5x, then you got the correct answer. And I can quickly see that this is not right because that gives me 12. That's not correct. So, and I just saw another error that I have. Hold on. I put plus. This is actually negative 2. Y'all probably pointed that. Y'all probably watching the video like, wait a minute, that's negative. That's a negative 2. So it's either going to be negative 2 times 1 or 2 times negative 1. So you do have 2 options here. It could be either one of those. So let's start with negative 2 first and see if that works. So the middle terms is going to be negative 6. The outer terms are going to be 4x. And when I add these together, I get negative 2. I'm trying to get negative 5. So that does not work. So let's try something else. Let's switch this around. Let's try putting the 2 over here. And let's try putting the 1 over here. Let's make this negative, make this positive. Okay. This is trial and error. I think you can already see why this is not the absolute popular way to do this. Because you really have to put numbers in there and try it out and see if it works. So I switched the 2 and the 1. I switched the signs also. And I got negative 3 and 8. When I add those together, I get 5x. I'm close. I'm trying to get negative 5. So if I switch the signs, then I will have it. Let's switch these signs. Let's make this, 2? Let's switch these signs real quick. So I'm going to put 2 over here, make this negative, and then put the positive 1 over here. Now this may give us our answer. And that gives me negative 5. Because I got negative 5, then I know that this is my answer. Now, you notice this is not the best way for me to do this. It works for some students, so I'm not going to say it's not the best for someone else. But I did kind of want to go through it a little bit to show you how it works. I would not personally use this unless I knew for sure. The only reason I would do this is if I didn't have all these options. If I only had 1 or 2 options on each side, then I would probably use this. But let's try it again. I mean, why not? Let's try it again and see if we can get another problem. Just for the sake of someone that may want to use this method. Let's say 14x squared plus 13x minus 12. Okay. This may be a good problem to do this because I don't want to do AC method with this either. If I had a calculator, I would do 14 times 12. But so let's write down all our options, right? This would be 7x, 2x. I multiply those, I get 14. And then you get 14x times x. You multiply those, you get 14. So you only got two options. This may be a good problem to do trial and error. And then with 12, this will be the problem over here. So you got negative 12. So you got 3 and 4. And both of those negatives could be with the 3 or the 4. And then you have 2 and 6. And then you have 12 and 1. And remember, the sign has to go with one of these numbers. So here are your options in putting minus sign with one of those. So I got to find something that works. I got to find something that when I add together, I can get the original middle term. So, okay. So let's start with 7x and 2x for the first terms. And let's just start with 3 and 4. I'm going to put a negative with the 3 and a positive with the 4. Just playing around with some numbers. I'm trying to get 13. So multiply your middle terms. That gives you negative 6. Multiply my outer terms. That's going to give me 28x. So 28 minus 6, that's not going to give me 13. The goal is 13. So let's change the numbers up. Let's switch these two. Let me put 4 here and 3 here. So that gives me negative 8x. And then this gives me 21x. So let's do 21 minus 8. Does that give me 13? Did I get it? Yay! I got it. I got it. So boom. So that's how trial and error works. Like you literally throw your numbers in there and then you try to just play around with the numbers and see if you can get the one in the original middle section. So that's trial and error. Not the most popular amongst students, but I mean, it's pretty helpful to have another tip, technique in your back pocket on how to solve these problems.